we got news. You are looking at the completed Helix. So some of you are probably going to realise at this point that there is not too much difference in the overall positioning and design, and you know that's sort of the idea. But the roadbed hasn't changed at all. It's the exact same roadbed, but as you can see, now it's a cantilever system. And we'll talk about some details for the moment, but you know, what you're going to see shortly is just a test run of a Class 350 doing a test run for me on the new Helix. So far everything's really good, all the wiring's complete. And as you can see, the advantage of using SetTrack is that it's a very, very rigid geometry, so the track doesn't bend or warp or anything like that. And now the descent is very, very well organised. It's not like it was before where there was areas of enormous changes in elevation and depth and all that sort of stuff. So now it's a gradual descent thanks to that accuracy of the cantilever system and the risers. So thanks to that, the trains can now run quite freely without any problems. And you can see here I've been testing trains all afternoon and no derailments at all. I'm thinking maybe what I'm going to do is stick some LED strips maybe along the outside so we can sort of show off the Helix and show off the trains. Maybe some RGB lighting might be pretty cool, but you know, more to come from that. So I've just got to stop the train because the Helix isn't actually connected up to the main line yet. It's on the bottom level anyway. It's still got some teething and relocating to do, and I'll show you about that in just a second. We'll bring the 350 back up now. So I'll just cut the camera and show you what needs to be done today, and just give you a bit more of a close-up on what we've actually done with the Helix. Just wanted to show you the design of the roadbed and how I get steam trains up at 2.5% grade, or in my case it's about 2.25%. But the important thing to note here is the use of foam. You can see here the threaded rod is actually clamping these two parts together. There is some additional support underneath to keep everything level, but the track is just nice and neatly nailed down as it would be normally, and everything is nice and level and smooth. There's very little chance of a train derailing on this. But the secret to getting trains up a Helix, especially steam trains from Hornby, Buckland, it doesn't really matter, is how you get the best adhesion. So if you want to pull a train of 8 coaches or something like that up a Helix unassisted, it's pretty difficult. I mean, you know, even some of the really big Hornby locomotives, the Duchesses, the Princesses, they struggle. And then you go to things like the A4s and the A3s, and they're just about as useless as you would expect. So when we get to actually pulling trains up hills, one of the most useful things that I have ever invested in is this thing called Powerbase, and this is a product from DCC Concepts. Very simple principle. So I've just got a little off cut of what we used to use, and I'll just change hands. So what you can see here is a piece of stainless steel, precision cut, and this is about not even a millimetre thick. And the idea is you glue it down onto your foam base like this has here, and with this, using some magnets attached to your locomotives, and these little magnets here, you can pick these up on eBay. These are N52 neodymium magnets, and you can get them in all sorts of shapes and sizes. I think this is about 20mm by about 5mm by about 4mm. You can get these things on eBay real cheap, but just to give you an idea of how powerful these are, bang, just like that, and that was less than 10mm away, and you can see just what I'm talking about. It's an absolute bloody nightmare. So that's how it works in principle, and even taking this away, I can show you there's a steel plate right here. Okay, that's how strong it is. Ah, you bastard, come on. Okay. So, I mean, it works. It actually works. You can't really beat physics, and the stronger the greater magnet is, and N52 is about as strong as you get, the more effective the traction or the extra traction will be for your locomotives. Now you can get a pack of etchers from DCC Concepts. They supply these little brass etchers. They look something like this. Honestly, I could be with or without these because some locomotives don't really allow for this sort of installation, and the other problem is these are a real pain in the ass to install underneath a locomotive. I mean, I've got some pretty big hands, as you can see, and trying to install these things for me is very difficult, so I tend to just avoid them. You can see they're nicely made. They give you different height options. You've got 4mm, 5mm, 6mm, 7mm, all the way up to 8mm, which I've used most of them. But you know what, honestly, I just tend to find that you can get these little bar magnets off eBay, stack them about 2-3 high watt, depending on the clearance underneath your locomotive. A dab of hot glue or some resin, and you can just glue them on there and they're going to stay there and go absolutely nowhere and get you the same results. Now again, that's up to you. Depends if you want to defile your locomotive, but at the sake of performance, I would say it's worthwhile. So that's how I get steam locomotives and other small locomotives up hills with long trains, and I would love to do a demonstration. In fact, there's a video I did not so long ago, well actually it was so long ago, but I reviewed the Thompson B1 in a video, and that was hauling 8 Mark 1s up this helix, and that was the old helix that had imperfected risers and all sorts of problems, and it still pulled up 8 Mark 1 coaches without a problem. But the reason for that is because it had these attached to the bottom. So it had 2 sets of these, one at the front of the drivers, one at the rear of the drivers, and it just makes it an absolute little champion when it goes uphill. And I'll see if I can grab a locomotive to show you, because I don't have too many on hand, but just give me a second. Okay, I'm back. So what I have here, and I've got to be very careful because it's very difficult to handle these things on camera, is a Britannia Pacific. So you can see here, it's lovely, lovely locomotive. And just fixed onto the bottom like that are the magnets. So we've got a 4mm and a 5mm, and one at the front, one at the back, and that just incredibly helps traction. And if I put this locomotive on the track, it's not going anywhere in a hurry. It's not going to be very easy or very difficult to, and I can already feel the difference. I mean, that's a lot heavier. So effectively it just puts a lot more downforce onto the wheels and makes it a lot easier for these things to gain traction. Because nickel silver is primarily used on the track and the wheels, it's polished nickel silver, by the way. The friction factor isn't probably as realistic as it could be, but you know, these are the things you have to deal with in model railroading. So that's my solution anyway. So really, really simple concept. You can buy these from Hatton's and various other places. It's just as simple as that. You can cut these little steel plates down the length. You could probably even make them yourself, but seriously, for the money, it's worth it. Just buy a pack of these. You get 60, 70 in a pack or something. It's enough to do about 5 meters or something like that. So, you know, again, with the video I'd uploaded previously, you do all the calculations for how many loops you need. You know how long the track is going to be. Another tool that I used to help me design this helix, and as well as the rest of this layout, let's put it up there, it's something different to look at. It was a software called AnyRail, and AnyRail is honestly one of the biggest lifesavers I've had in the experience of making this layout, because it has preloaded track libraries. You can quite easily align this, and for the most part, except for the modification I made to the junction and entrance here into platform 1 and 2, everything I had planned out in AnyRail has pretty easily come to fruition, because all the dimensions lined up, everything was great. So it's worthwhile. So before I go, I'm just going to quickly show you what needs to happen first. Just going to slowly drop the camera down so you can just get a better angle of the lower level. So you can see that's the lower level, and this is the entrance into the fiddle yard. It's been there since the layout first started, but as I've now realised, it's going to have to be modified. And there's a nasty mess of wires under here, so just bear with me. I'm going to do my best. I'm just going to get some light under here. Okay, that's much better. So as you can see, this is where the track ends, just up here. That's where it originally used to, and that's the track that now comes off the helix. So these points need to move over, or I need to increase the curve of that to join up there, and that way the trains are going to get in and out a lot better than they did before. So that's an absolute mammoth job. All this wiring, these are all the wires that I've been remediating them, so they've all got to be repositioned on the bottom of the table up here. These are for all the points on the top. It's a nasty mess of bloody wires, so I've got to fix that. But outside of that, progress is going really, really well. Hopefully by the weekend I should have this up and running and have trains running around the layout for the first time in probably about 6 months. I haven't actually had a full-length train successfully negotiate this layout for about 6 months, not since the helix was dismantled anyway. So that's pretty much all I have for you today, guys. What I'm going to do now is just show you the clips of me building the helix for your enjoyment, and I'll put some commentary over the top so you understand what we're doing. But oh yes, by the way, before I forget, so the logic behind why I did it this way, and as you can see, it's clear air. There's no obstructing things getting in the way. I can get in here now and clean the track with a lot more ease than I used to before. These can quite easily be tensioned. This threaded rod can quite easily be tensioned. The track can very easily be cleaned. Trains can very easily be removed. So there are advantages to making these cantilever helix systems. Again, it depends on your needs. So that's how I've gone about doing it. It's a lot better. It may not look so great at the moment, but you know what? It's a lot better than I probably anticipated it would be. But anyway, I'll leave you with some footage of me making the actual helix. You'll see me drilling out the holes for the risers and attaching this to the board. About after that, it's very simple. You just thread the bolts through like I have there, and you can see the overhang over this side just along here. Tighten them up and just rest the road bed on top and join them together. That's how easy it is. So anyway, that's all for me from the moment. I hope you've enjoyed the explanation, or at least look into the helix system that I have used. I wish I could do more at the moment, but for the time being, that's all I can offer you. So